Hi, my name is Zebo Long. I'm a senior researcher working at SUEZ WTS. In this video, I'm going to introduce you to a novel technology called ZeeNAMMOX. Currently, I'm leading ZeeNAMMOX process development, and I believe ZeeNAMMOX is a choice of solution to sidestream nutrient removal. ZeeNAMMOX combines PNA biofilm with ZeeLung MABR. Here, PNA stands for partial nitrification and ZeeNAMMOX. PNA are the two main biological reactions in ZeeNAMMOX. ZeeLung MABR is a carrier of the PNA biofilm. To get everybody to the same page, I will first provide a brief introduction to PNA process and ZeeLung MABR technology. And then I will describe and explain how ZeeNAMMOX works, followed by some information on sidestream market and existing technologies. At the end, I will wrap up with ZeeNAMMOX value proposition. PNA is the most biologically efficient pathway for nitrogen removal. To get rid of ammonia nitrogen from the wastewater, the conventional nitrification and denitrification approach mainly includes 3 steps. In step 1, ammonia nitrogen is oxidized into nitrite nitrogen by AOB. This step is called partial nitrification or partial nitration, or PM for short. In step 2, nitrite nitrogen is oxidized into nitrate nitrogen by NOB. Step 1 and step 2 together are called nitrification. Nitrification requires oxygen supply and therefore consumes lots of energy. In step 3, nitrate nitrogen is reduced into nitrogen gas by heterotrophs, a process called denitrification. This process requires biodegradable COD, and in many cases, external carbon source or biodegradable COD source must be added to improve the denitrification performance, which is also very costly. By contrast, PNA process only requires a portion of ammonia nitrogen oxidized into nitrite nitrogen, and then ZeeNAMMOX bacteria will consume the nitrite nitrogen and the remaining ammonia nitrogen, discharging around 80%, 89% of the nitrogen as nitrogen gas and 11% as the nitrate nitrogen. As a result, PNA process saves up to 57% of the oxygen and almost 100% of COD, as compared with conventional nitrification and denitrification approach. ZeeLung MABR is the biomass carrier that breathes without the use of bubbles. ZeeLung MABR is a proprietary membrane product of SUEZ, and it is also the brand name of the technology for its application in the mainstream. ZeeLung MABR is a modularized product from ZeeLung cords to ZeeLung modules and to the final products of ZeeLung cassettes. A cross-section of the ZeeLung cord with biofilm, the gray layer here, is shown in this figure. As you can see from this figure, ZeeLung cord consists of a central support with hollow fibers surrounding the central support, and some wrapping material are holding the hollow fibers in place. This unique structure makes ZeeLung MABR very robust and therefore a very long lifetime. In ZeeLung MABR, air or oxygen is supplied to the lumen of the hollow fibers. Oxygen diffuses across the membrane wall into the biofilm, while the other nutrients diffuse into the biofilm from the bulk liquid from an opposite direction. This is a phenomenon called counter diffusion. Candle diffusion provides a leach for slow-growing bacteria, such as nitrifiers. This is why ZeeLung MABR, sometimes we call it the form of nitrifiers for its application in the mainstream. The membrane material has very high permeability for oxygen, which allows very high oxygen transfer rate in ZeeLung MABR. And the bubbleless aeration enables high oxygen transfer efficiency in ZeeLung MABR. As a result, ZeeLung MABR saves more than 75% of energy as compared with surface aeration or fan bubble aeration. In addition, the installation of ZeeLung MABR is simple, as shown in this figure here, and the process control is reliable because of the use of the gas phase sensors rather than liquid sensors. So now we know both PNA and ZeeLung MABR are great technologies, and we would like to combine these two to have ZeeNAMMOX. An ideal biofilm in ZeeNAMMOX is shown in this figure here, AOP in the inner layer of the biofilm close to the membrane surface where the oxygen is supplied, and ZeeNAMMOX in the outside layer of the biofilm where the oxygen is depleted. The actual biofilm in ZeeNAMMOX would be different, and a proper process control has to be implemented to suppress NOB to avoid too thin or too thick biofilm. In addition, we also need to manage heterotrophs in ZeeNAMMOX. And of course, the most important thing is to promote AOB and ZeeNAMMOX in ZeeNAMMOX to maximize the nitrogen removal. We have achieved complete NOB suppression in almost all ZeeLung pilots except those for comparison. Based on the PN stoichiometry, we derived the TIN-RR to AOR ratio as the indicator for NOB suppression. TIN represents for the total inorganic nitrogen, and AOR represents the ammonia oxidation rate. The theoretical value of this ratio is 0.89 for PN, a process. A value equal to or greater than 0.89 indicate complete NOB suppression. Let's look at the figure on the right here as an example. In R1 and R2, this ratio was greater than 0.89, which indicate complete NOB suppression in these two reactors. By contrast, R3 has much lower ratio, which indicate that the NOB was not completely suppressed. Note that we have confirmed the PNA activities in all the reactors by ZeeNAMMOX activity batch test and the qPCR test. We can achieve complete NOB suppression by process air management only. In this slide, I'm going to share one of the mechanism with you, which is called air reversal. Let's zoom in to say a single fiber in ZeeNAMMOX. At time 0, the process air goes through the hollow fiber from the top to the bottom. Due to the higher oxygen level in the inner air, the DO in the biofilm at the top section of the fiber is higher. It's relatively high, which will promote the growth of both AOB and NOB. As the DO level becomes lower at the bottom of the fiber, DO limited conditions in the biofilm might occur, which would inhibit NOB growth. If we run the process here like this all the time, there will be NOB growth in the biofilm, at least for the biofilm at the top section of the fiber. The air reversal strategy is to switch to switch the process air direction at a certain time interval. By doing this, the DO limit conditions will switch between the top section and the bottom section. This will disrupt the NOB, and NOB will be all out-selected over time. We have been developing new control strategies to maximize the nitrogen removal in ZeeNAMMOX. As you can see from this figure here, the current AOR and the TIN removal rate are almost doubled as compared with those values 2 years ago. Using the current ZeeLung product, the volumetric loading rate of ZeeNAMMOX can be as high as 1.35 kilograms nitrogen per cubic meter per day. The future generations of ZeeLung MABR products will further increase the membrane packing density, which will further increase the volumetric loading rate of ZeeNAMMOX. All this will make ZeeNAMMOX more competitive. ZeeNAMMOX is a simple solution that is resilient. A simplified ZeeNAMMOX process flow diagram is shown in this figure here. The function units include a pre-treatment unit such as the drum screen for the trash removal and a process tank that contains ZeeLung MABR cassettes. ZeeNAMMOX is a flow-through process without any second clarifiers for the solid separation or any pumps for the sludge return. The process here is optimized in ZeeNAMMOX to increase the PNA rate and while keeping NOB suppressed. The mixing and scouring air is also optimized to have good mass transfer and the proper biofilm thickness. In addition, we might enable exhaust recycle to further reduce the energy for the mixing and scouring. ZeeNAMMOX is targeting sidestream market while getting ready for the mainstream application. Sidestream nitrogen removal is critical because it can reduce 20% of nitrogen load to the mainstream, which will improve and secure nitrogen discharge compliancy in the mainstream. The sidestream nitrogen removal is also a solution of no energy cost. It can save 10 to 15% of aeration energy for a wastewater treatment plant. This is why the sidestream market is growing at a rate of 50 to 120 million US dollars per year. As a new player, ZeeNAMMOX has to compete 3 main competitors, namely Demon, Pax, and ZeeNAMMOX or Helpers. I will wrap up with ZeeLung value proposition. First, ZeeNAMMOX saves energy. It can save more than 70% of energy as compared with Demon and ZeeNAMMOX. It also saves more than 20% of bioreactor volume as compared with these two technologies. ZeeNAMMOX is a simple solution that is resilient. The use of gas phase sensor rather than liquid sensors for the process control greatly improves the process reliability. Last but not least, ZeeNAMMOX is also a green technology with the potential of reducing 90% of N2O emission. In one sentence, ZeeNAMMOX is a choice of solution to sidestream nitrogen removal. Thank you for your time. If you have any questions, contact me. Thank you.